Hey there from AstroNUT. Ready for an epic journey into the cosmic unknown? Let's dive into the mysteries of black holes and the universe's hidden secrets. Black holes are renowned for their formidable capacity for destruction, but the tantalizing question remains, can these cosmic enigmas themselves be obliterated? What if we dared to push the very boundaries of physics to their limits, perhaps even beyond, potentially triggering cataclysmic consequences for the universe as we know it? Picture, if you will, the audacious scenario of crafting a minuscule black hole within the confines of the AstroNUT lab, an entity possessing a mass akin to that of Earth's moon. In our daring endeavor, we aim to disintegrate this celestial marvel. To set the stage for this cosmic spectacle, let us embark on a theatrical detonation, igniting the complete nuclear arsenal of Earth in close proximity to our inquisitive black hole. A resounding boom reverberates through the cosmos, signaling the commencement of our audacious experiment. Black holes, those insatiable cosmic devourers, indiscriminately consign any hapless entities venturing across their event horizons to an inescapable fate. Be it matter or energy, once past the event horizon's point of no return, all elements succumb to the inexorable gravitational pull. Notably, Albert Einstein's iconic equation, E=mc², illuminates the critical relationship between energy and mass. As energy is funneled into a black hole, it augments its mass in a directly proportional manner. This ever-expanding mass corresponds to an increase in the black hole's size, ensnaring all within its gravitational grasp. Let us now venture into the intriguing realm of antimatter. Antimatter and matter, like cosmic archenemies, engage in a cataclysmic annihilation dance upon contact. The question that beckons is this: what unfolds when we propel a payload of antimatter equivalent in mass to that of Earth's moon into the voracious maw of our celestial companion, the black hole? Regrettably, the inexorable phenomenon of identity erasure dominates this celestial tango. Remarkably, it matters not whether the infalling substance comprises matter or antimatter. As it traverses the event horizon, its entire essence is subsumed into the growing mass of the black hole. In the enigmatic realm of black holes, distinctions blur, and the past becomes irrelevant. This identity erasure, characteristic of black holes, bestows upon them an eerie simplicity, akin to that of elementary particles. Consider an electron, one of the universe's most fundamental constituents. Its existence is encapsulated by just three defining attributes: mass, spin, and charge. Astonishingly, this simplicity is mirrored within the mysterious confines of black holes, entities that embody mass, rotation, and even electric charge. Consequently, an intriguing question arises: can we envision the obliteration of a black hole by introducing an antipodal black hole composed of antimatter? Delving further into this enigma, we introduce the concept of an anti-black hole. Analogous to the duality of particles and their corresponding antiparticles, we envisage a counterpart for black holes, the anti-black hole. By design, an anti-black hole possesses equivalent mass but features an inverse electric charge. Envisioning the convergence of these cosmic counterparts, we contemplate their collision. Yet, alas, the outcome proves underwhelming as the electric charges merely amalgamate and negate each other. Post-collision, the result remains a black hole, albeit one twice as massive yet devoid of charge. Our quest for the destruction of the black hole endures. To enact the true annihilation of a black hole, a more profound contemplation ensues: the dissolution of its event horizon. The event horizon, an abstract threshold marking the boundary of no return within the black hole's gravitational clutches, plays a pivotal role. A thought experiment ensues. Picture the event horizon as an impenetrable fortress, safeguarding the unfathomable singularity ensconced within. To pierce this fortress, we must unleash the powers of rotation and charge, pushing them to the brink. When either rotation or electric charge exceeds a critical threshold, an extraordinary phenomenon materializes: the event horizon crumbles. This phenomenon can be likened to the repulsion generated by a rapidly spinning object, which seemingly endeavors to eject nearby entities. The black hole's omnipotent gravity ultimately prevails, but if rotation intensifies beyond a critical limit, the event horizon dissolves, liberating nearby objects from their celestial prison. Similarly, electric charge exerts its influence. As charge accumulates within the black hole, a tipping point looms on the horizon. Once charge attains a critical magnitude, the familiar event horizon disintegrates, exposing the singularity within, a naked singularity. This singular point of infinite density retains its gravitational grip, yet it no longer imposes an irrevocable confinement upon objects. They can now approach it and retreat. This transformation signals the dismantling of the conventional black hole, transforming it into a novel celestial entity. Yet, the question endures, can we surmount the formidable barriers posed by physics to witness the birth of a naked singularity? The audacious answer beckons us to embrace the concept of overloading. To enact the dissolution of the event horizon, we must confront the black hole with an overabundance of charge or angular momentum, surpassing the gravitational pull of mass. A cosmic imbalance must be forged, rendering the event horizon vulnerable to dissolution. Let us delve into the intricacies of charge overloading. Consider a charged black hole, one possessed of an electrical affinity. As we introduce an influx of electrons, particles abundant in charge relative to mass, they are met with electrostatic repulsion. The influx of electrons instigates a cascade of charge accumulation within the black hole. An increasingly negative charge begins to manifest, resulting in heightened electrostatic repulsion. However, a pivotal juncture arises, where the electrostatic forces reach a crescendo, obstructing further electron entry. The black hole steadfastly refuses to accommodate the overabundance, resisting the fate of charge-induced dissolution. A parallel narrative unfolds in the realm of angular momentum. As we approach the black hole's upper limit of rotation, it reaches a point of equilibrium, refusing additional intake of angular momentum. Yet, a tantalizing possibility emerges. Some audacious physicists contend that a narrow window of opportunity exists, permitting the initiation of overloading. Precisely timed injections of matter, introduced mere moments before the black hole's rotation saturates, offer the prospect of overstepping the threshold. Nonetheless, an inherent paradox emerges with the dissolution of the event horizon. As this protective boundary disintegrates, the singularity remains ensconced within, ready to ensnare any curious voyagers. While objects may approach the singularity, they do so without witnessing their impending fate. The singularity resides not in their present but in their future, subtly distorting the fabric of spacetime itself. As one crosses the event horizon, time and space intermingle, and the journey toward the singularity inexorably propels them into the future. Therein lies the cosmic riddle. One cannot reverse this trajectory, just as time's flow remains immutable. The singularity, their ultimate destination, eludes immediate perception. However, a vexing quandary accompanies the unveiling of a naked singularity, one bereft of an event horizon shroud. It could herald a seismic shift in the foundations of physics, possibly unraveling the very fabric of our understanding. Singularities, at their core, represent regions of infinite gravitational intensity, distorting space and time to such an extent that predictability falters. As the integrity of spacetime fractures, notions of cause and effect unravel. Predictive capacity evaporates when the very concepts of where and when dissolve into a cosmic maelstrom. Within the boundless abyss of a naked singularity, infinite energy courses, further compounding the unpredictability of outcomes. From this enigmatic crucible, anything may manifest without discernible rhyme or reason, from clusters of mundane bananas to enigmatic swarms of vanishing socks or even entire solar systems. The predictable foundations of causality and the familiar edifices of physics falter, thrust into uncertainty's embrace. The existence of singularities is theoretically substantiated, birthed from the gravitational collapse of massive entities. Yet, it is widely conjectured that nature shrouds them with the protective cloak of an event horizon, preventing their unbridled emergence. This safeguard preserves the cosmic order and shields the universe from the capricious consequences of unfettered singularities. In essence, black holes, often cast as the enigmatic cosmic villains, paradoxically serve as cosmic sentinels, averting the emergence of naked singularities that could undermine the universe's bedrock principles. It follows, then, that to pursue the destruction of the event horizon is to risk the very underpinnings of our understanding of physics. As per our current comprehension, a singular pathway exists toward the annihilation of a black hole: patience. Over time, all black holes gradually emit minuscule particles in a phenomenon known as Hawking radiation. This process leads to the gradual depletion of a black hole's mass, culminating in its eventual evaporation. This inexorable cosmic clockwork, driven by Hawking radiation, erases both the event horizon and the specter of a naked singularity. The timespan required for a black hole's complete evaporation correlates with its initial mass. In the case of our diminutive black hole, akin in mass to a speck of cosmic dust, the process unfolds over a staggering expanse of time, approximately 10 to the 44th years, an epoch spanning 10 billion trillion times the current age of the universe. In summation, the destruction of a black hole is indeed a plausible prospect, but it calls for patience. We must allow the natural progression of Hawking radiation to pave the way, gradually diminishing the celestial behemoth until it fades from existence. During this interval, a multitude of enthralling scientific pursuits beckon us here on Earth, offering a trove of knowledge and comprehension for those with inquisitive minds. Thank you for exploring the intriguing world of black holes and the mysteries of space with us. If you enjoyed this journey, please consider supporting our channel by giving this video a thumbs up, sharing it with fellow cosmic enthusiasts, and subscribing for more mind-expanding content. Your support fuels our quest for knowledge. Until next time, keep gazing at the stars and reaching for the unknown.